Now, this is the fourth and final challenge this year, Salient Object Detection Challenge. So here's the outline for this session. We will first introduce the data set and the task, and then we will dive into more details about this challenge. Then we will announce the challenge winners and present the analysis of this year's results. This is the first year we're running this challenge, and we're very excited to share the results. So let's start with introduction. Salient object detection is a task of producing a binary mask for an image that deciphers which pixels belong to the foreground object versus the background. So in simpler words, algorithms separate a foreground object versus the background in an image down to the precision by pixel. And each pixel in an image is either assigned foreground or background. So note that there is no category to the foreground objects. The objects can be anything that is identified as the foreground in the image. In this data set, images are real-world scenario images originated from blind photographers seeking to better understand their surroundings. Now let's take a closer look at the challenge itself. There are in total 32,000 images in this data set with annotations. We split the data into 3 subsets: training, validation, and test. The training and validation sets are released to the participants to run their algorithms, and the test set is used to evaluate the results at the resolution of 720 by 720. The evaluation metric here, we use mean absolute error, which we call MAE for short. To simplify this math here, MAE shows the proportion of pixels in an image that are assigned incorrectly. So that would be foreground wrongly assigned as background, or background wrongly assigned as foreground. So we have benchmarked in total 7 modern salient object detection algorithms for this challenge. And the best performing model achieves the score of MAE at 0.17, which is still 0.15 worse than human performance in MAE. So we can see there's still a huge gap between what modern algorithms can do and what human can do. And to fill in this gap, we'll release this challenge this year, and we're very happy to see great participation this year as the first year. There are in total 11 teams who submitted their results. So now, without further ado, let's announce the winners this year. We're pleased to announce the top 2 teams, starting from the second place. And the second place this year goes to Team Li from Shigen University. Congratulations to them. Their MAE score is 0.03 and well done. So I apologize if I didn't pronounce the team name correctly. Congratulations. And finally, the first place this year is Team Minivision from Artificial Intelligence Research Department, Minivision, Nanjing, China. Congratulations. We also achieved a 0.03 in MAE as the best score here. This is an amazing result that greatly exceeds the baseline. So well done to all. We're very excited to see so many innovative algorithms achieving great results. This is a huge step. And finally, let's dive into some analysis of this year's results and share some future challenges. It is very exciting to see that we're now only at 0.01 behind human performance. Now that we're very close to human, it is important that we identify what is critical for the algorithms in our data set. So we performed fine-grained analysis on the top 3 submissions to identify the challenging cases in the data set. We observed that algorithms perform poorly on foreground objects without presence of text on them. So this finding actually suggests that text on foreground objects can help algorithms to locate them more effectively. And in terms of the coverage of objects, which is the size of the objects in the image, we observed that algorithms struggles with small and large objects. And in terms of boundary complexity and image quality, we also observed that the models struggle with foreground objects with more complex boundary and images with lower quality. So all these analyses suggest that there's still much to improve, especially with images and with certain features that we are able to identify. So we look forward to future innovations. And with that, I will wrap up and go into the presentations from the winner team.